The universe is vast. And when we look up at the night sky, we are not staring at a cold, static backdrop. We are looking at a cosmos teeming with countless, uncharted worlds far, far away. A sprawling frontier waiting for us to find a way across. For scientists, humanity's expansion into the cosmos is no longer just a distant vision. It is the greatest theoretical challenge of our time, the quest to uncover the how. Make no mistake, breaking out of our cradle will be a brutal, monumental struggle. Every mile will be fought for. But it is a struggle we will face eventually. Driven by our innate, restless impulse to reach for what lies beyond. Yet, physics, as we understand it, presents a seemingly insurmountable problem: the unfathomable distances and the absolute speed limit of the cosmos, the speed of light. To reach the stars, we must either bend the rules of space-time, bypass them entirely, or radically alter ourselves so that time ceases to matter. There are many pathways through which this expansion might be realized, and every single one of them challenges not just our technology, but the very definition of what it means to be human.
Let's begin with the path usually displayed in fiction, the one that supposedly makes space travel trivial, faster-than-light flight, FTL. In the reality of physics, however, accelerating any object with mass through space past the speed of light is strictly forbidden. The theoretical loophole: we don't move the ship through space, we move space around the ship. This is the concept of hyperspace, or more precisely, the Alcubierre drive. Instead of breaking the cosmic speed limit, this warp drive contracts spacetime directly in front of the spacecraft and expands it behind it. The ship itself rests peacefully inside a flat, spacetime bubble. On paper, the spacecraft isn't moving faster than light at all. The bubble of spacetime is surfing through space.
However, we are far from building it. This technology exists only as a mathematical framework, not as an engineering reality. We do not know how to generate gravity or energy in the massive, unfathomable amounts required to warp spacetime, let alone how to manipulate it safely. To warp space even slightly, we would need to bend spacetime by an immense margin using negative energy density, a theoretical concept often tied to exotic matter with negative mass. This level of engineering is far beyond our current reach. It is a technology reserved for a much more advanced civilization than our own. Likely an advanced Kardashev Type II civilization capable of harnessing the total energy output of an entire star. Still, even though it feels infinitely far away, the mathematics say it is theoretically possible. But what if we don't need to warp spacetime to conquer cosmic distances? What if we simply maximize the absolute limit of rocketry? This brings us to a much more immediate, albeit staggering engineering feat: harnessing the power of raw creation.
In rocketry, everything is governed by the Tsiolkovsky rocket equation, which states that the higher the energy potential of your fuel, the less weight you need to carry to accelerate. To escape our solar system efficiently, we need the highest energy density physics allows: antimatter. To harvest antimatter in quantities large enough to power interstellar voyages, a developing Type II civilization wouldn't look for it in deep space. They would build it. By constructing a partial Dyson sphere around our Sun, we could capture a fraction of its immense, unfathomable energy output. This near infinite power would then feed massive solar system sized particle accelerators. By colliding particles at near light speeds, we can harvest pure antimatter. Because matter-antimatter annihilation yields a perfect conversion of mass to energy, it gives us an incredibly low-weight fuel solution with unparalleled energy potential.
With an antimatter drive, the brutal tyranny of the rocket equation is finally tamed, allowing heavy starships to achieve a significant fraction of the speed of light safely and realistically. Yet, even with antimatter, you are still carrying your fuel with you. What if we left the fuel behind entirely? This introduces the concept of beam-powered propulsion, laser-driven light sails.
Instead of heavy onboard engines, a spacecraft is fitted with an incredibly thin, ultra-reflective sail stretching across kilometers, weighing mere grams. The propulsion mechanism relies on pure radiation pressure. A massive array of high-powered lasers stationed in orbit or built across the solar system focuses a titanic, gigawatt-level laser beam onto the sail. Photons, though massless, carry momentum. As they strike the reflective sail and bounce off, they transfer their energy, pushing the vehicle forward with continuous, relentless acceleration. Within days, a probe can be propelled to 20% the speed of light.
But what if the secret to interstellar travel is to not physically travel at all?
A much more elegant and feasible option for an earlier Kardashev Type II civilization involves sending a small object with minimal mass to a distant solar system. Because the object is small, it requires vastly less energy to accelerate to high speeds, making it achievable much sooner. Aboard this miniature probe is a quantum-entangled communication device. If the bandwidth through this quantum-entangled communicator is sufficiently high, the distance between stars effectively collapses. The probe could map and transmit data from an exoplanet, a star system, or beyond, instantly sending it back through the quantum tunnel without lag. On Earth, this data is unpacked into hyper-advanced simulations. While not physically present, an entity could navigate and experience a deeply distant point in space in real time. Imagine it like a monitor's resolution. The more advanced the technology and the higher the bandwidth of the tunnel, the more flawless and indistinguishable from reality the simulation becomes.
Let's take this a step further. Once the technology matures enough to send even a tiny payload of self-replicating nanobots across that distance, the paradigm shifts. These nanobots could manufacture physical avatars on the surface of the alien world. We could walk physically on an exoplanet, feel its atmosphere, and touch its ground, even though our actual consciousness, our true self, remains safely at the origin location. An expansion born entirely of data. Another profound approach avoids interstellar travel entirely by using the light the cosmos has already given us.
By building an incredibly massive array of telescopes stretched across our solar system, we could achieve an unfathomably high visual resolution. Because light takes time to travel across space, looking farther into the distance means looking directly into the past. We could feed the data from these cosmic telescope arrays directly into virtual realities at our origin location. We wouldn't just be looking at a distant planet through a screen. we would be generating an entire virtual reality where we can experience a distant point in space as it existed thousands of years ago.
It is a deeply spiritual and reflective concept, exploring the living history of the universe in real time, traveling into the past without ever leaving home. If we do choose physical grounded expansion, however, we run headfirst into the concept of the generation spacecraft. These massive ships travel well below the speed of light, accepting that the journey across the dark void between stars will take centuries or even millennia. The crew that leaves Earth will never see the destination. Only their distant descendants will step onto the new world.
This cold reality becomes beautifully viable if we pair it with the concept of advanced simulated realities. The thousands of generations tasked with crossing the empty abyss wouldn't have to suffer within the claustrophobic confines of a metallic hull. While their physical bodies reproduce to maintain the population, the crew could spend their entire lives inside vast, beautiful, and flawless digital worlds. The ship is merely a physical life support shell. Their actual existence is spent in a digital paradise. Falling into a very similar category is Cryosleep. Like generation ships, this method accepts incredibly long travel times, but circumvents the need for active generations by halting biological decay. The key might already exist in nature. Certain wood frogs survive subarctic winters by producing natural anti-freeze agents, advanced cryoprotectants, that prevent their cellular structures from collapsing or being shredded by ice crystals when frozen. If we can understand and apply these biological preservation mechanisms to human physiology without destroying it, deep space cryosleep becomes reality.
Yet, this path carries a striking spiritual and psychological weight. You are essentially traveling into the future. If you sleep for thousands of years to reach a star and eventually decide to return, your origin location will have progressed by millennia. You would return to a completely transformed home, a ghost from a forgotten era, trying to navigate a world that has evolved far past you. Whether humanity manages to warp the fabric of spacetime, harvest the raw power of antimatter, ride beams of coherent light across the void, project its consciousness through quantum tunnels, or freeze its biology to survive the slow voyage, one truth remains clear. Expanding into the universe will fundamentally reshape what it means to be human.